don't really like it. I don't like using it. But I am going to show it to you because it does help some people. But like I say, from grade 9, you should know how to do 90% of the stuff we're going to do today. So let us begin with, just a simple review of what indeed you already know. Does anybody remember the definition of a polynomial? Does anybody remember what it is? Can anybody give me an example of one? All right. So let's start. A polynomial is a I was going to write mathematical, but I'm too lazy, is a math expression. Now, I need to spend a moment to talk about that word expression. We've talked about it a few times this year. What is an expression versus an equation? Carlin. An equation, has an equal sign, which means an equation has an answer. An expression has no equal sign, so there is no answer. Understand? With an expression, all you can do is simplify it or change how it looks. You cannot find the answer. And let me give you an example of that. The square root of 48. That's an expression because there's no equal sign, yes? So all you can do with that is simplify it, which of course you would break it down to 4 root 3, right? But if I gave you this, does that have an answer? Yes, because there's an equal sign. You can tell me what y is. Does everybody understand? So polynomials are, at your level right now, are never going to have an answer. You are only going to be able to simplify or change how they look. Everybody cool? And you've already done a lot of work with polynomials, even though I haven't called it polynomials. Okay? Okay. So, it is a math expression containing coefficients variables and constants. I'm going to highlight those three things because I want you to be aware of what they all are. We all remember what a coefficient is. We were just talking about it when we did radicals, yes? It's the multiply number, yeah? So I'm going to write out a polynomial. And I'm going to use the same colors to highlight what in that polynomial is what, just to remind you. So what in that polynomial is a coefficient? 3. Is there another coefficient? Technically. No. No. 1. Technically, right, Eden? And where would that 1 be? In front of the y. Everybody cool with that? Right? Let's not forget there's that snaky 1 that lives there. So technically it's there, right? Okay. What are the variables? X and y. Okay? And finally, what is the constant? 9. Why is it constant? Because it's always 9, right? No matter what happens in this polynomial, no matter what x and y are, after I've multiplied x by 3 and multiplied y by 1 and added them together, the last thing I'm going to do is take away 9, right? Everybody cool with that? Yeah? Okay. Oh, you know what? I'm going to add in a squared there. Please add that squared in. Does that squared change the fact that we have a polynomial? No. Because all that squared does, it means x is multiplying again, right? And multiplying is no problem. What is missing, you will notice there are no radicals anywhere in this definition, yes? And there are no irrationals. Everybody with me? You can see that, right? Now, I'm going to do one thing here, and all you have to do is say yes or no. Is this a polynomial? 2x squared. Yes or no? You don't even need to write it down. Just think. Is it a polynomial? Yes or no? Yes. Excellent. Good. Well done. Okay. What about this? The square root of 4x. Is that a polynomial? So this one is. What about that one? I have two A students. One is saying yes, one is saying no. Is that a polynomial? In my earlier example, when I put root 48 up there, what did I say you should have done to it? Simplify it. So what's the square root of 4? So what's this really? 2x. Is it a polynomial? Yes. Does everybody understand why? That joke never gets tired. It's x. Does everybody understand why? X, y. That old teacher joke. Algebra. Your x is, I don't know how to find your x. She left. Don't ask me why. That algebra joke. You guys know that one, right? Because you appreciate a fine quality joke like that, I would guess. Right? Okay. Everybody's cool with that one? Okay, what about this one? X to the 1/2. Is that a polynomial? I said exponents are allowed. That's got an exponent. What is that really? Square root of x, isn't it? Is that allowed? No radicals are allowed. Is that radical? Can I simplify it any more than that? So is that a polynomial? No. Is everybody cool? All right. So let's move on a little. There's 3 polynomials that get special names. Monomial, binomial, trinomial, which again you should remember from the 9th grade. A monomial is a single expression consisting of any combination of coefficients, coefs, vars, and exponents. And then please notice when it shows up, it is capitalized, so it must be important. Multiplied together. So what do I mean by that? I'm going to erase over here. Is that a single coefficient variable or exponent? Yes. Everyone understand? It's one thing. Cool? Okay. So that is a monomial. Right? What if I put a 2 in front of it? Is that a monomial? Yes, because it's multiplying with the variable. Everybody still cool? Is that a monomial? 2x squared. Yes, because it's all still multiplying together. Okay? What if I put a y there? Is that a monomial? Yes, because it's still all multiplying. What if I put a z to the 4th and a q? Is that still a monomial? Yes, because it's all multiplying together. Everybody cool? All right. What if I just did this? Is 4 a monomial? Yeah. Everybody cool? Yeah. Okay. So what then is a binomial? If a monomial is a single expression, what's a binomial? Two what? Two expressions. Or a binomial is two monomials. Connected by, what's the only math that we didn't talk about in the first one? Connected by addition. So, 2x monomial. 3y monomial. How do I make that a binomial? I make it I put a plus or a minus. Mr. Myers, you said it's addition. What is subtraction? Adding negative numbers. Doesn't actually exist. Everybody cool? You guys are smart kids. What then is a trinomial? 3 monomials. And after that, there's no names for it. After that, it's just a polynomial. Poly is from the Greek word for many. Nomial is from the Greek word for numbers. So many numbers. Everybody cool? The degree of polynomials is important for one thing and one thing only. When you get to very complicated math, they like to write it in a nice order. That nice order depends on the degree of polynomials. It's the only time I'm going to put any notes on it because I don't care about the degree of polynomials because we are never going to do math that complicated. But I want you to have seen it once. So you can't say down the road in like 5 years, I have never ever heard of the degree of polynomials. Okay? The degree of polynomial is very simple. It is the sum. Don't write that. Sorry. It is the greatest sum of variable exponents in any one term. So, 2x. What's the only exponent in that monomial? 1. Because we don't write the exponent of 1, yes? So this guy is a degree 1. Everybody cool? 2x squared plus y. How many variables are there? How many variables are in this binomial? 3 variables? 2, x and y. So what degree is he? The degree is the greatest sum of variables variable exponents in any one term. That's the biggest, right? So what degree is this guy? This guy is degree 2, because we only care about the variables. Everybody good?
You don't add the variables together, like if it's x.
Well, no, because it's only in one term. So then the third one is this kind. 2x squared y plus 3x y. What is the degree in that guy? I look only at the variables. And what do I do with their exponents? Greatest sum of variables. What do I do with their exponents? Add them. So what's this guy? 2 and what's this guy? 1 and 1. So this guy has 3, right? Is that the greatest number? So this guy is a degree 3 polynomial. Everybody cool? What is, and don't write this one down. Well, you could write it down even if you want. What's the degree of a constant? Degree is variable exponents only. So what degree is that? 0. Everybody cool? And the only reason we care about it is because later in life, when we write big polynomials, we write them out in descending degree. So the biggest degree goes first. And we write it alphabetically. So if there's an a cubed in your polynomial somewhere, that term is going to be first when you write your final answer. If you have a teacher that really, really cares. Since it's the first you're seeing of it, will I really, really care? No. Everybody cool? All right. Let's move it along to something that you guys already know. You guys already know how to do this. We are not going to break out algebra tiles, but we are going to draw this once. We're going to draw one of everything because when you see it drawn once, it sometimes helps. What is this right now saying to me? What math is happening here? That is multiplying. You are saying it is 5 times x plus 1. Yes? X plus 1 is a binomial, right? So if we were going to draw it, we would draw it thusly. A long bar makes an x. A little square makes a 1. So right now I have drawn x and 1 as soon as the computer thaws. Since neither one is shaded in, they are both positive, right? How many of those do I need according to my math? 5. There's one of them. 2, 3, 4, 5. And that tells you the answer. In the middle here, I have 5 x's and I have 5 1's. And the reason we do this is to show you that the factors live outside. There's my 5, and there is my x plus 1. The factors live out there, the answer lives in the middle. Now, a great many of you don't need to see this because you understand the distributive property, but some kids don't. In the old days, teachers would teach how to do this with algebra, no pictures. And 1 or 2 kids wouldn't get it. And the teachers would then go to them and they would show them this. And then the kid would say, oh yeah, okay, I get it. But then about 10 years ago, they decided that every kid needed to learn how to do this. And some kids don't really get this. So they were actually losing marks, even though they could do the math. Hey. Yeah. Yeah. Okay. If you understand the next thing I'm about to show you, then you can promptly forget about this. Aight? If you don't understand the next thing I'm about to show you, then you may want to revisit this. Okay? Algebraically, this way we used a picture. This is what is actually happening, isn't it? Right? I had 5 unknown values and I had 5 known values, right? When we do algebra, we are using symbols instead of reality, right? How many cups am I holding up? 2. If I asked you to write down how many cups I was holding up, all of you would do that, correct? Everyone agrees? Because there's 2 of them. But that is just a symbol that we use to show 2, right? That's one thing. We drew a 2, but it meant 2 things in reality. You with me? Okay. So algebra uses symbols, 0 through 9. So what we had was 5x plus 1. And what that actually means is I have 5 x's, and then I am adding 5 1s to get an answer of 5x plus 5. Now, 5x plus 5 is not real, is it? Because what's real is what we just drew. 5 of those x's in 5 little boxes. This is symbols to show that. Right? Because math guys are lazy. And as the world got more complicated, we had to invent numbers. Back in the old days, they didn't have them. Everybody good? Now, the shortcut to this is simply what you already know from exponents. The distributive property, which is this. X times A plus X times B. Now, the problem with this is every kid understands it when you write it this way. Every kid gets it. It's no problem. The problem comes when we change the looks, like always. All right? Everybody's cool with that, yeah? All right. That's what it's called, distributing. Because that x goes to everything. Many, many math teachers have many cute little names for that. But your university professors or your electrician school professors or your plumbing professors, where you have to do a buttload of math as well, will not have cute little names for it. So I do not have cute little names for it. I call it what it is. Yes, Robert. Please do. All right? So, show a picture and an algebra solution. Like I said, we're only going to use it once or twice. For the picture, I have x, because that's one of the factors, so it's on the outside. And on the other side, I have 2 x's and negative 4, which means we just color in the boxes. Then the middle is where the answer goes. So I have this x, and I'm multiplying it all the way across this x to make a giant x what? X squared. Then another x squared. Then 4 bars. What wins, the negative or the positive? Negative wins, because when you multiply two things with a different sign, the answer is negative. This is now my answer. How many big X squareds are there? 2x squareds. How many little guys? Minus 4x's. That's the picture. I don't want to use them anymore. Can everybody do them? Terrific. Now let's do this the way math should be done. Technically, this is x times 2x minus x times 4. We know this from our exponent laws. That's 2x squared. And we know that is minus 4x. The shortcut is we just multiplied in there. Everyone is good? Great. Don't bother drawing a picture for the next one. Just tell me the answer. What does that equal? Three x squared plus 6x. Right? And it seems easy. And everybody should be able to do it, right? Because all you did is you took that term and you multiplied it by both of them. Right? What do I have here? What do those brackets do to x plus 3? What do brackets do? Brackets don't multiply. What is the purpose of the brackets? Why did we use them in the exponents unit? How did brackets change this? Why? What did the brackets do? The brackets grouped the negative with the 2, right? So what are the brackets doing here? They're grouping the x and the 3 into one single thing, yes? So this is telling me that some unknown number plus 3 is stuck together, yes? So this is a factor, isn't it? Because that whole group is multiplying by this whole group. Right? So if that's one of the factors, and I'm only going to draw the picture, you don't need to if you get it. X and 3, right? That's one of the factors. So it goes on the outside of a rectangle. What's the other factor? X and 2, yes? So let's multiply them. That x stretches out to make a giant x squared, yes? Then I get 1 bar, 2 bars, because that times them, right? Now I go to here. That one, there, there, there. And then that and that. 1, 2, 3, 4, 5, 6. And what's my answer? X squared plus 5x plus 6. Everybody cool? Now here's where the problem starts with the distributive property. All of you already can do it super easily, but when I write this out, x plus 3, x plus 2, everybody starts getting in trouble. If there was no 3 there, what would you do with x? Pretend that 3 is not there. What would you do with that x? You just did it twice. What would you do with that x? You would distribute it, right? Okay. Now, what if that x wasn't there and there was just a plus 3 there? What would you do with the 3? Distribute it. So if they're both there, what do you do with both of them? You distribute them. That x distributes first. What do you get? What's x times x? X squared. What's x times 2? 2x. Then you would distribute the 3. What's 3 times x? 3x. Now, I've already got some x's, right? So I'm going to keep those x's together. And then 3 times 2, what's that? Plus 6. I've got no other numbers, so it's out by itself, leaving me a final answer of x squared. 2 x's and 3 more x's is 5 x's, and 6 is by itself. And you can see that you get the same answer. Now, a great many teachers spend a great deal of time discussing shortcuts and nicknames and all kinds of things you guys can use to help remember how to do stuff. I personally like to show you how to do stuff. Right? That's what you did. Does that make sense to everyone? I brought the x through, I brought the 3 through. That's what I should do, right? Okay, that sets up this little memory tool that a great many of you will hear a lot of from other teachers in your math career. FOIL. The problem with it is it works in only one spot when it is binomial and binomial. It doesn't work anywhere else. So spending a year talking about it doesn't really help anybody. But showing you how to do it will help you. FOIL stands for first, outside, inside, last. And it only works for binomial times a binomial, which is all going to show up on my screen eventually. X plus A, X plus B. First will be in red, the first two things you see. Outside will be in blue, the outside two things you see. Inside will be in green, the inside two things you see. And last will be in gray, the last things you see. If that helps you, use it. But again, it only works here. Will we sometimes have polynomials that are bigger than binomials? Yes. So we have to know what is actually happening. So let's do what we just did here. You don't need to draw a picture if you can do it with algebra. If you're drawing a picture, draw a picture. If you're not, not. Some people don't draw the arrows. Some people do. It's totally up to you with what you want to do. I find the easiest way to do this is to start with the first one and distribute. X squared plus 4x. Then I go to the second one and I distribute. Negative 1 times x is negative x. And I put the x's together. And I make a stack. What's negative 1 times 4? Negative 4. And then I just add it up. X squared. 4 take away 1 is 3x. Negative 4 is all by itself. Negative 4. Everybody cool? Easy peasy lemon squeezy. Now here's the problem. You need to understand the principle that is happening here. Because, as I said, we get bigger polynomials than 2 terms, right? So what if I gave you this? I left a bunch of white space here on purpose. What if I gave you 2x times x squared plus 3x plus 7? What would you do with that? I would recommend it, or you can just pay attention, because this is not new principle. This is a new example. If you understand the principle with which we are working, then you don't need to write anything I'm about to do. But be aware that it does get more complicated. Maybe you need this example. What do you need to do here? Because this is a trinomial now. So what do you need to do? How many distributions must you make? 3. The 2 has to go to the first one. And what is it? 2x cubed. Remember, we have to remember everything from the last 10 years of math. So there's exponents here. Then I must distribute again. What happens there? Plus 6x squared. And then I must distribute again. What happens there? Plus 14x. Do you understand that? Great. What then would happen if it was this? Now how many distributions must I make? 6. Because I must distribute the x, and then I must distribute the 3. Correct? So when I distribute that x, what do I get? X cubed plus 3x squared plus 7x. Does everybody see what I have done? Everyone's cool? Then I got to distribute the 3, don't I? So what's the first thing that's going to happen when I distribute the 3? I'm going to hit that and get what? 3x squared. Where should I write 3x squared? Where would be a good way to write it so it stays organized for me? Underneath the x squared that I already have there, correct? What's the next one going to be? What's 3 times 3x? 9x. Where should I write 9x so it stays organized? With the other x. And what is 3 times 7? 21. Just 21. It's all by itself because there's nobody else to match it up with. Then it's all nice and tidy, isn't it? X cubed, 3x squareds and 3 more x squareds is what? I'm adding them up. I've got 3x squareds, then I got 3 more x squareds. How many x squareds do I have? 6 x squareds. Why isn't it x to the 4th? Because I'm adding, I'm not multiplying. 7 x's and 9 more x's. (16 x's plus 21). Everybody cool? Now you should really understand the principle. So don't write this down because I'm not even going to do it. If I had this, now how many distributions would I need to do? 9. And I need to make 3 layers, wouldn't I? Everybody cool? All right. Your work is whatever page that the next one is. It says assignment, I think. It's not an assignment. It says draw a picture. I don't even care. You can do it algebraically. Just, can I see your book? Because my book is different. Thank you, Noah. You guys are doing 122. Let's do 122 to 124. But there's going to be some things there that trick you, so be careful. Now, listen, please. What's due tomorrow? The review, pages 114 to 117. They are marks, right? The stuff I just assigned you is practice, yeah? So what is your job tonight? 114 to 117. Tomorrow we'll go over it, we'll mark it. It's a short day on Thursdays, yes? So we'll finish off 122 to 124 tomorrow in class and go over them all. Because there are some that are going to trick you. You're going to do some of them wrong because you all say, I get it, I get it, I get it. But you don't. Okay? So tonight you're working on this. And then on Thursday, we're doing page 122 to 24. We're going to finish them Thursday. Once we do that test, or once we do that review tomorrow and mark it, we can have the test any time after that. Right? I don't generally like doing tests on Fridays because attendance is poor. And I don't generally like doing tests on Mondays because your people's brains are mush. So in general, you should be expecting your test next Tuesday on everything to do with exponents and square roots and cube roots and fourth roots and so on and so on and so on. Okay? Okay. I'm going to do this. Unit 3 test. Approximately Tuesday. Because something always happens. Okay? Is everybody good? Okay, we're going to be leaving here pretty soon. I know that I do not need to remind you of this because you are a classy bunch of individuals. But I'm going to remind you of it anyway. When we go out to that assembly, we are quiet, we are respectful, and we are not using our phones or other mobile devices to record any of it. There has been enough tragedy based on clowns with their phones about this situation. All right? Mr. Como gave me a long speech I'm supposed to read to you, but I felt it was too nice to explain how horrible it would be if a phone was out for this ceremony. Okay? Because it doesn't allow me to give my opinion on the guy or lady who filmed the first thing. Because we're not supposed to give our opinions on that. But I don't care. I will give my opinion on it. Excellent. That will happen in a few moments. I can't remember exactly when. It's scheduled for 10:30, right? if it actually happens at 10:30, it will happen. But again, as I said, things always get a little off kilter, right?